Hi, today we'll be exploring the database HarperDB. This is part of our presentation for CS5200, the Database Management Systems class at Northeastern University. This is an overview of what we will be covering today. So first we'll have a look at HarperDB to introduce it and to find out what it's used for. Next, we'll compare HarperDB with MongoDB and SQLite as well, which are two of the three databases that we've explored in class. Next, we'll also have a look at uses for HarperDB and where it is best suited. And finally, we'll have a look at CRUD demonstration created with HarperDB. A little about us before we move further. My name is Semaa Amin. I'm a Master's of Science in Computer Science student at Northeastern University. My project partner is Yvette Green. She's also a Master's of Science in Computer Science student at Northeastern University. So let's start looking at HarperDB and why it is the underdog of databases. So HarperDB is a SQL or NoSQL database management platform. It is fully indexed, doesn't duplicate data, and runs on any device from the edge to the cloud. HarperDB is a geo-distributed database with hybrid SQL or NoSQL functionality in one powerful tool accessed via a REST API. It runs anywhere, presenting a single interface across all deployment architectures. It has hybrid cloud capability. It runs on public cloud, edge data centers, on-premise, and or on the field. It enables horizontal scalability with peer-to-peer architecture and leverages parallel processing for vertical scalability. It also provides low latency edge data replication, effectively the evolution of CDN, but for your data. It also has real-time data synchronization between nodes, and a single node of HarperDB can actually handle up to 100,000 requests per second, and it can globally replicate data at the speed of the internet. So let's have a look at some comparisons between MongoDB, which is one of the most popular databases with HarperDB, as well as SQLite with HarperDB. HarperDB averages 37.9 times faster than MongoDB, and it can go up to 98 times faster than MongoDB when reading documents, up to 20 times % faster in writing documents, and overall in concurrent operations it outperforms MongoDB as well. And the benchmark for which these tests are made and the methodologies can be found in the description box at the bottom of this video. HarperDB is less than half of the price of MongoDB Atlas, and it requires less compute, which then translates to lower cost of scale. It also does not duplicate data, unlike MongoDB, so that's why it will have lower storage costs. And HarperDB natively supports SQL and NoSQL, so you have less memory required. So here are one of the other things to compare is the SQL capabilities. You can perform and execute complex ACID-compliant SQL queries on JSON with no data duplication, something that MongoDB struggles with. And you can utilize joins and complex operations, array functions, GeoJSON, and math.js easily. HarperDB is built natively as a set of microservices, making development and integration easy and seamless. HarperDB utilizes a single endpoint for all operations, and its RESTful nature makes it stateless, stable, and scalable. It also has a very simple and sleek GUI for data management. It code examples in most languages, and drivers for analytic tools and other third-party applications can easily be integrated, and you can use Postman collection to get you started. Next, we'll compare HarperDB with SQLite. The main test between these two is performance. Before we dive into what the results are, the scope of this test, HarperDB was compared in contrast with SQLite 1 on a Raspberry Pi 3 Model B2. There will be a link to the benchmark test document between SQLite and HarperDB in the description box below. So HarperDB outperformed SQLite on all test cases, and on average was 581% faster. The biggest difference that was seen was at the 1000 record insert mark, where HarperDB was 901.3% faster than SQLite, and the round trip for that was 20,955.88 milliseconds for SQLite, compared to the drastic difference of 2,305.06 milliseconds for HarperDB. The average test results can be seen in the charts just right here. So let's have a look at its possible uses in the industry. So it can be used in many different places, and it's the underdog because it hasn't been utilized, or it hasn't been popular enough to be utilized in all of these different industries that it would be so successful in. So the first obvious place to be used is industrially. It could be used to capture data on anything, whether it's machinery, performance, rotation, temperature, output, weather, you name it. The second is using it in renewable energy applications, whether you could use sensors to be able to remotely discover what the wind speed is, the temperature, cameras, data monitoring, automate controls based on installation sensors and such. It allows you to do more, or to improve products in renewable energy, as well as get more real-time data faster and more accurately in order to improve future products. In transportation, as electric cars and self-driving cars are becoming more and more popular, we could use a database like HarperDB to reduce bottlenecks in traffic, and to find out, to get more data on current traffic infrastructure and be able to improve that. Next, we have gaming. It could be used to improve the response time and prevent delays in games. And finally, in retail, we could use it to monitor the sites and provide more accurate inventories, as well as be able to more quickly detect and block bots from over-purchasing or any other retail online retail issues. Next, we'll have a look at a CRUD demo that we created with HarperDB using Node.js and Express. And this demo is of a book application, a book exchange application that we called BookPals. We've been working on creating a book exchange application for the past term, and we've used SQLite, we've used MongoDB, and we've used Redis in combination with MongoDB to create different versions of this book app. And we went ahead and did another one of these versions with HarperDB to see how it stacks up and how easily we were able to create it. And we were able to create this application with the help of some of the online tutorials that HarperDB has released. So here's a demo of what the web application actually looks like. Here's a quick look at the demo of our application. So we're going to try to add a book here. I'll be adding one of my favorite books. Alright, so we can see here that Pride and Prejudice was added onto the list of books that we have in our book exchange, and if we refresh the window, it'll still appear here. Next, we'll try to edit one of the books. So let's try to edit 1984, and maybe write it down this way. And save, and we can see that it also has updated successfully. And next we'll try to delete. Actually, before we try to delete, let's have a look at the database that we have here. So before I added this window is showing us the database before I added the Pride and Prejudice book. So if we refresh, we should see the Pride and Prejudice book pop up here, as well as perhaps the title of the book changing here. So we'll have a look at that, as well as the new addition of a new book. So refresh, there we go. So the title did change, and Pride and Prejudice was added to the database. So now we'll maybe try to delete something out of the database. Let's try to delete Treasure Island. So we'll do that, and we'll press delete, and we'll go here and refresh again, and we can see here that the database deleted Treasure Island from the list of books that we have here as well. Just to go over the database really quickly, so here's the schemas that we have. We have the book schema, and we have the book records in the tables, and everything that we have entered here goes into this database here, and it also provides an ID for each entry as well. And that's all for the demo for this application. So next we'll have a look at the project structure, and we'll go into a code walkthrough of the essential CRUD code after that. So first, we've set up our index.js file, and we've connected that to the app.js file, and over here we've imported all the dependencies and we've set up our application. And here we move into the first step of the CRUD application. So we add a book here, or we try to add a book here, and then we get the user data from the request. And here we insert a new record into the database, and then if there's any error, we return this. And after creating a new record, we direct back to the home page. So after creating that, we were able to add a book to the database, but we weren't able to get it to display on our app. So we needed to have something where we can search by value, and also a way for us to be able to display that data in our EJS table. Next, we'll have a look at how to edit. We'll have a look at how we will be able to update or edit a book record. So to update the query, we use these operations, and after updating, again, we direct back to the home page, and if there's any errors, we return an error. And finally, we have the delete operation, and that's the delete query that we have there. And after everything, we can just export that to app, which then gets fed into the index.js file. And that's all for the code walkthrough. Thank you very much for listening. We hope you gained something from listening to us.